Hello everyone, I am Anjali Brahmane, Faculty of Civil Engineering Department from Vishwabharati Academy's College of Engineering, Ahilyanagar. Here I am representing online lecture series for fluid mechanics subject. Today's topic is fluid kinematics. Now, first will we see the definition of the fluid kinematic. The branch of fluid mechanics which deals with the study of velocity and its acceleration of the particles of fluid in motion and their distribution in shape, their distribution in space without consideration of any forces or energy involved is known as fluid kinematics. Motion, the location of the fluid particle in space at different type. Next is method of describe the motion of fluid. There are two motion. First method. First is Lagrangian method and second Eulerian method. First is Lagrangian method. The observer concentrate on the movement of single particle, the path followed by the particle and changes in its velocity, acceleration, density, etc. are described. The observer has to move with the particle movement. In this method, observer moves with motion of fluid, and the method is complex and difficult to understand the fluid motion. The second is Eulerian method, and the observer concentrate on the fixed point particles. In this method, observer does not move with the motion of fluid, and the simple method and it's very commonly adopted to understand the fluid motion. The observer remains stationary and observes changes in the fluid parameters at the particular point only. Next, the types of flow lines. The first is path line, second streak line, third streamline, and fourth stream tube. The first, the actually path followed by fluid particles as it moves during a period of time is called as path line. It shows the direction of velocity of same particles at successive instant of time. And a path line can intersect itself in a steady flow. The path line coincides with the streamline, and while in unsteady flow, it may be between different streamline during an interval of time. Next, streak line, the curves that gives an instantaneous picture of the location of the fluid particles which have passed through a given point is called as streak line. Some example of streak line is the lines formed by smoke particles injected from nozzle or smoke coming out from the chimney. Next, now see in figure, streak line nozzle smoke generator. The streamline, the imaginary line drawn in the fluid in such a way that the tangent to any point gives the direction of motion at that point is called as the streamline. The path line, streak line, and streamline remains identical in steady flow. Figure of streamline. Next, stream tube. The imaginary tube consists of number of streamlines forming a boundary surface which does not permit the fluid across. It is called as stream tube. The shape of stream tube the changes from one instant to another because of change in position of streamline. The figure of steam tube. Next is types of fluid flow. The first is steady and unsteady flow. Second, uniform and non-uniform flow. Third, laminar and turbulent flow. Fourth, compressible and incompressible flows. Fifth, rotational and irrotational flows. And the sixth, one, two, and three-dimensional flows. First, steady flow and unsteady flow. The steady flow, in which the fluid characteristics like velocity, pressure, density, etc. at a point do not change with time. And unsteady flow, in which the fluid velocity, pressure, or density at a point changes with the respect to time. Next, uniform and non-uniform flow. Uniform flow, in which the velocity at given time does not change with respective to space. Its length of direction of the flow. And non-uniform flow is in which the velocity at any time changes with respect to space. Next, laminar and turbulent flow. The laminar flow, in which the fluid particles moves along well-defined path or streamline, and all the streamlines are straight and parallel. Now see in figure, turbulent flow. This types of flow is called as streamline or viscous flow. Next, turbulent flow. Definition of turbulent flow is the fluid moves in very irregular path or zigzag way. Now see in figure, turbulent flow. The Due to this movement of fluid particles in a zigzag manner, the iris formation takes place, which are responsible for high energy loss. See figure, turbulent flow to zigzag line and zigzag way and laminar flow. Next, compressible and incompressible flows. The compressible flows, in which the density of the fluid changes from the point to point. The density is not constant for the fluid. It is compressible flows and incompressible flows, in which the density of fluid does not change from point to point. The density is constant for the fluid. Next is rotational and irrotational flows. The rotational flows, in which the fluid particles while flowing along streamline also rotate about their own axis. And irrotational flows, in which the fluid particles while flowing along streamline do not rotate about their own axis. Next, 1, 2, and 3-dimensional flows. First, one-dimensional flows in which the flow parameter such as velocity is a function of time and one space coordinate only. Second is two-dimensional flow in which the velocity is a function of time and two rectangular space coordinate. The third is three-dimensional flow. The three-dimensional flow in which all the velocity is the function of the time and they are actually perpendicular to direction. Next, critical, subcritical, and supercritical flow. The first critical flow, when the Froude numbers is equal to unity and mean velocity of flow. Subcritical flow is when the Froude number is less than 1 and mean velocity of flow. And third is supercritical flow, when the Froude number is greater than 1 and mean velocity of flow is V is velocity of flow. Next, sonic, subsonic, and supersonic flow. First is sonic, the flow for which Mach number is equal to unity. Subsonic flow is the for this Mach number m is in between range of 0.4 to 1.0, and supersonic flow is the for this Mach number is always greater than unity but less than 6. Okay, thank you.